hopefully these general guidelines will help you to solve complex transformation problems. So we've got a domain, the z-plane, and we've got some sort of subset of the z-plane, and it's being mapped by w onto the w-plane, uv, w equals u plus iv. And basically there's only two possibilities. Either we know this set and we're wondering where it ends up, or we know where it ended up and we're wondering where it came from. And it's the same process each way round. It doesn't make any difference really, because if w is f of z, then z is the inverse of f of w. So you can think of this as the domain and this is the range, or for the inverse, this is the domain and this is the range. Doesn't make any difference. So let's say we know about z, we know this. So how do we start? One, you write down the domain. That's the set that z is on. Write down what you know. And then you sub in z equals in terms of w. So there's going to be no z's left in the domain, it'll all be w's. Now, you might have to do a little bit of work. Just put this in brackets. You probably need to rearrange your w equals f of z. Probably need to rearrange w equals f of z into z equals some function of, let's call it g, some function of w. Actually it's f minus 1, isn't it? Not that it matters. Then having done that, number 3, all you're going to do now is you're going to fiddle around with it until you recognise it. And sometimes you've been told what you're going for, so you know you're going for a circle, so you know you're probably going to be completing the square and that kind of thing. So if you know about z, you know the domain and you're wondering what the range is of the function, where it ends up, you write down what you know, you sub in z equals, which might require a little bit of work, and then you fiddle with it until you recognise it. So what about if you know about w? It won't surprise you to know that this is basically the same process. We start by writing down what you know. Obviously you do know something. And then, guess what you do? You sub in w equals, because you know about w. And for this one you won't need to do any work because you've been given the function in the form w equals more than likely. So wherever it says w, put in what w is. And then third, same thing, you just fiddle around with it until you recognise it. And then you're done. So big things to remember are that z is always x plus iy, w is always u plus iv. So make sure your variables are the right way around and follow these steps and you should be successful in your transformation. Now this is a bit more tricky, I admit. Let's say that the domain we're given, we're told about z and we're told that, so this is x and y, that what we're trying to find out about w is f of z and this is u plus iv, and we're told that x plus 2y minus 1 equals 0. So we're on some sort of line, made up what that looks like, but we're on some sort of line in the z-plane. We want to find out where it maps to. Maybe it's a circle, maybe it's a line, don't know. Now obviously, if we follow the previous set of steps, you write down what you know and then you sub in z equals or f equals. Well, there is no z and there is no f, not explicitly. There's a z kind of in here somewhere, but we can't sub in, so we need a different strategy. Now, what we know is something about z. If we know something about z, then start by writing down z equals, and then this is your function. So you'll need to do a bit of work, do the work to get z equals. And the reason that I've started by writing z equals is that I know about z. Now this is gonna, let's say it's w, 2w plus 1, just for the sake of argument to make it obvious what's happening. Now what we need to do is we need to sub in w equals u plus iv, because we must be working in component form, we must be working in terms of the individual real and imaginary parts here. So we sub in u plus iv, and then you're going to rearrange it into the form something plus I something, real part and imaginary part. So you fiddle around with it until it looks like that. 2u plus 1, that's the imaginary part, plus I, and then 2v. Now, the reason this is good, let's keep that z equals going so we know what we've actually got here. The reason this is what we need is because z is x plus I, y, and we know a relationship between x and y. So now that we've done this work, what we can now do is sub the x and the y into what we know about x plus 2y minus 1 equals 0. So what's that going to give us? It will be 2u plus 1 plus 2 lots of 2v minus 1 is 0. And then what we need to do is just fiddle around with it the same as before until we recognise it. Fiddle until recognise. So in this case, well, I think if I do 2u plus 4v equals 0, divide both sides by 2 maybe, I recognise that as a straight line. V equals minus a half u, so that is a line with gradient minus a half going through the origin. So something, I don't know, something like that. So those are the steps. They're a bit more complicated, and I'm going to go through them one more time in case, just so that they settle in, and also for if you are given something in terms like in the range instead of in the domain, because we had a domain here. So, just going over it again, but from the other perspective. Let's say that we've got x plus iy here, and we're going over to u plus iv here. But what we're told about is u plus iv. We're told that u squared, let's say it's a circle, u squared plus v squared is 4, say. So that's what we know about, and because we know about it, we start by writing w equals. Let's make up a nice easy one. Let's say w equals 4z. That'll do. Let's not make it too complicated. W is 4z. Now, we need to sub in. We start with w because I know about w. I need to sub in what z is in its component form. Sub in z equals x plus iy, because I have to be working in components here. W equals 4 x plus iy. W is 4x plus 4iy. And we're fiddling around with it. Get it into something plus I something, because this is your u and this is your v. No, actually I've already done that really easily because I made up an easy one. So u is 4x and v is 4y. This is my u, this is my v, and I can sub into what I know, which is u squared plus v squared is 4. So that gives me 4x squared plus 4y squared equals 4. So 16x squared plus 16y squared is 4, dividing everything by 16. X squared plus y squared equals a quarter. So that's a circle. The centre is the origin. The radius squared is a quarter, so the radius is a half. So, it's a little circle like that. And that's where it came from. So the steps are, write down what you know. If what you know is w, write w equals whatever function it is. If what you know is z, write z equals whatever function it is. Sub in this in component form, either z or w. Then fiddle around with it into its real and imaginary parts, because the real and imaginary parts are what you can sub into what you know. Fiddle until you recognise it. Just one more thing before I go. Let's say that you've got your z-plane here, x plus I, y, and you've got a transformation, u plus iv, going over there, and you've already done the previous steps, and you've worked out that this circle here maps to this line here. So you've already worked all that out. But what you want to know is, where does the inside of the circle map to? So you know the circle itself, I'll do that in red. The circle itself, all these points map onto this line. But where does the inside of the circle go? Now all you have to do is pick a point, either on the inside or the outside of the circle, it doesn't matter. In this case, look, the origin is on the inside. So I think, I usually Unless the origin is on the red line, I take the origin because it's easier. But you can take any point. So the origin is no x's and no y's, and all you need to do is sub that into your function, w equals f of z. So literally have a look what happens to the individual point, origin, and see where it goes. If it goes over here and lands there on the left hand side of the line, then all of the other points near it, around it, like this, they will also land here somewhere. So you can see that the inside of the circle goes to the left hand side of the line, and the outside of the circle must go to the right hand side of the line. It's a pretty easy little tip.